So we're going to be discussing today parallel lines cut by a transversal and the angles that result from this setup of lines. So let's first start in this first box. You have gone over this before in previous grade levels, so some of these will sound familiar, some of them will be new. We're going to start with some vertical angles. Vertical angles are angles that fall around one intersection of one of the parallel lines in the transversal, and these lines are congruent with one another. So vertical angles are congruent. What does congruent mean? They're the same size and shape. The size and shape are the same. So we are going to gather some different colored highlighters, and we're going to pair up the angles on here that are corresponding vertical angles. So we're going to start with angle number 1 up here. Angle 1 and angle 4 are vertical angles. You'll notice that this is a larger obtuse angle here at 1, and 4 is also an obtuse angle, where 2 and 3 are acute angles. These two are congruent, and they are the vertical angle pair. 2 and 3 are also a vertical pair. These are vertical angles. Can you find another set of vertical angles like 1 and 4? Another set would be 5 and 8. And lastly, we have 6 and 7. So again, vertical angles are congruent angles along one parallel transversal intersection. Okay. Next, we're looking at our alternate exterior angles. Alternate exterior angles are going to be similar congruent angles that are more or less mirror images of one another between the intersections of the two separate parallel lines and transversals. So again, these are also congruent. And one example, we're looking for the exterior angles. What does exterior mean? Exterior is outside, and alternate another word you can use for alternate is opposite. So if we are looking for the opposite outside angle of 2, the alternate outside angle, our outside angles are 1, 2, 7, and 8. Remember, we said they're congruent. Between 1, 7, and 8, which angle appears to be congruent with angle 2? We've got angle 7. So the other pair of alternate exterior angles is 1 and 8. Okay. Next, we have alternate interior angles. What is the meaning of the word interior? Inside. And alternate, we said another word we could use for alternate could be opposite. So it could be on the opposite side. So our interior angles in this setup are 3, 4, 5, and 6. What would be the congruent interior angle that could be paired with 3 and be called its alternate interior angle? Right, 6. 6 and 3 are congruent. They're on alternate sides of this transversal. This here in this situation is our transversal. Again, transversal is just a fancy way of saying a line that cuts through two others. It's a transversal. Okay, now let's identify two other alternate interior angles. What are the two other alternate interior angles we have? Right, we have 4 and 5. They are congruent and they are on alternate sides of the transversal. Okay, now we have corresponding angles. Corresponding angles are also congruent. And they are in the same position on the opposite parallel lines. They're going to be on the same side of the transversal. So they're on the same side. So either to the left of the transversal or the right of the transversal on the opposite parallel lines. So one example would be 1 and 5. 1 and 5 are both in the same position of their specific parallel line. Here we have our transversal. This is our parallel line 1. This is our line 2. 1 is on the top left of the transversal and parallel line, and 5 is on the top left of the intersection of the transversal and line 2. So what's another? We have 2 and 6. 3 and 7. 4 and 8. Okay. And now here's something you may remember from 7th grade. Now we're going to talk about supplementary angles. Does anybody remember what total supplementary angles add up to? They add up to 180 degrees. So, for example, looking at our parallel lines and our transversal, 180 degrees would be a flat angle, a straight angle. So 1 and 2 add up to 180 degrees. If we look at this second example, 1 and 3 also add up to 180 degrees. If you add the measurement of angle 1 and angle 2, the total would be 180. If you add the measurement of angle 1 and angle 3, you would also add up to 180. Another example is 3 and 4, and also 2 and 4. We also have 5 and 6, or 5 and 7. And lastly, 7 and 8, and 6 and 8. Each of these pairings, if you add up the totals of the angles, will add up to 180 degrees. And lastly, we have complementary angles. You learned about complementary angles in previous years also. Does anybody remember how much that 2 complementary angles adds up to? They add up to 90 degrees. 90 degrees, is a right angle. So, an example of 2 complementary angles is 10 and 2. If we add up the totals of the angle measurements of 10, angle 10, and angle 2, these will add up to 90 degrees. This gives us a right angle. So angle 10 plus angle 2 equals 90 degrees. Can anyone see another example? We have angle 3 and angle 9. If you add the total angles, the total measurement of angle 9 and the measurement of angle 3, you get a right angle, and it adds up to 90 degrees. So angle 3 plus angle 9 equals 90 degrees. So let's write down the definitions of each of these types of angles so that we have something to refer to when we're looking back at our notes and using it for our work. So alternate interior angles. We said that those were on opposite sides of the transversal. And they're located inside the parallel lines. For our corresponding angles, we said they were in the same position. On opposite parallel lines. And on the same side of the transversal. Sorry, ran out of room there. For our alternate exterior angles, we said they were on opposite sides of the transversal. And they were located outside the parallel lines. And lastly, we have our vertical angles. These are the opposite angles that are created by two intersecting lines.